Today on the Perception in Action podcast, how can a constraints-led approach be used to develop tactical behavior in team sports? Can a step game approach focused on understanding be combined with the CLA to improve tactical knowledge and team synergy? How does this all fit with Gibson's distinction between knowledge of and knowledge about? So it's time for a call to action. Hello, and thanks for joining me. This is Rob Gray from Arizona State University. I've been on a now over 25-year journey as a researcher, professor, and high-performance consultant to understand how we acquire and adapt our perceptual motor skills. Welcome to the Perception in Action podcast, where I discuss how psychological research can be applied to improving performance, accelerating skill acquisition, and designing technologies. If you're a coach or an instructor, my goal is to help you bridge the gap between research and application, and to connect your experiential knowledge with skill acquisition and motor learning theory. I want to help take you from using practice design recipes to becoming a master chef who can manipulate the key ingredients to come up with your own innovative training methods. If you're a student or fellow academic working in the skill acquisition field, I hope to keep you up to date on the latest studies and help you get to know the people working in this area. Finally, if you're developing training technologies, I hope to help you incorporate good motor learning principles in your design, pull out key performance metrics from the data, and design effective studies to evaluate your product. To learn more, help support the podcast, and/or work directly with me, please check out perceptionaction.com. Now on to the show. In today's episode, I want to look at how the CLA can be used to train tactical behavior in sports. For this, I'm going to review a series of recent studies by Ana Ramos and colleagues, which have tackled this question from a variety of different angles. To foreshadow, this will cover issues including how does tactical behavior emerge in a team? How can we measure this in terms of the movement behavior? Can it be enhanced by combining constraints manipulations with more traditional approaches that seek to enhance understanding and declarative knowledge about tactics? And finally, I want to use this as a springboard to address a question I've been asked a lot recently. What does a good outcome look like when you manipulate constraints in practice? The first study I want to look at is a systematic review by Ramos and colleagues recently published in the journal Psychology of Sport and Exercise. In it, the author's goal is to review research that has investigated the use of constraints manipulations for training tactical behavior and team coordination. Here we're mostly talking about things like use of small-sided and conditioned games, which I covered a bit back in episode 89 when looking at the effectiveness of the CLA. In particular, in this review, the authors were focused on research which has examined some aspect of team synergy. In the ecological approach, it is proposed that team tactical behavior emerges from the formation of synergies under the face of constraints. The formation of a synergy at a team level is analogous to the development of motor synergy within an individual athlete. That is, a group of relatively independent degrees of freedom, here the players on a team, spontaneously and often temporarily work as a functional unit, for example when attacking or defending. It is further proposed that these synergies develop as a consequence of athletes' perceptual attunement to shared affordances. That is, the different players on a team learn to pick up and act on the same opportunities for action in the environment. For example, two or more teammates see the same opportunity for a drive at the goal at the same time based on the available information. For more on the concept of shared affordances, please check out episode 117. Diving into more detail and bringing in some dynamical systems concepts, Arujo and Davids have proposed that team synergies exhibit 4 key properties. First, dimensional compression, which is a reduction in the number of degrees of freedom produced by coupling previously independent degrees of freedom. So essentially, we can describe the behavior of the team with fewer values than we had at the start. Second is reciprocal compensation, which is the tendency for one player's action to influence opponents' behaviors so that task goals can be accomplished. Third is interpersonal linkages. This can be seen in some of Duarte and colleagues' work where the interpersonal distances between players serve as control variables. Finally, the fourth characteristic is degeneracy, which, as I've discussed several times on the podcast now, is the ability to solve the same movement problem using different solutions. I will return to some of these later, but let's get back to this systematic review. With the search criteria of looking for studies that manipulated constraints and assessed some aspect of team synergy, Ramos and colleagues identified a total of 26 papers. Overall, there were some key messages pulled out. First, the vast majority of studies have focused exclusively on male athletes. Second, Only the first two properties of synergies, dimensional compression and reciprocal compensation, have been studied. Third, most studies have given only pre- and post pictures of how things changed after the constraints manipulation, with not much analysis of the underlying processes involved. That is, how different constraints manipulations actually have their effect. Interestingly, a finding coming out of a few of the studies is that when variability in performance context is increased in practice, there is a decrease in the speed at which team coordination develops. I will return to this seemingly negative result in a bit. Finally, the authors identify a key issue that I've also seen in how the CLA is being used in practice: a lack of clear overall purpose. Quote, most cross-sectional investigations of team performance in training sessions have failed to explain why different constraints manipulations were integrated and implemented into practice, and what individual or collective problems, i.e. technical or tactical, were targeted. Moreover, usually such protocols are implemented during a small part of the training session without the provision of information about intersections with other parts of organized training programs. End quote. And quote, future studies should present an appropriate contextualization of constraints manipulation inside the whole training process. Why and how are specific constraints manipulated? What technical, tactical problem does the manipulation seek to resolve? I myself have observed a few practices that have included some type of CLA manipulation, primarily because I think the coach has heard about it somewhere and finds the idea appealing. But frequently, these manipulations seem to lack a clear purpose. What effect are you hoping to have by adding the constraint? Are you trying to get your athletes to move away from a particular solution? For example, holding the ball too long and always attacking down the same side of the field? Are you trying to encourage them to explore and be more creative? Is there a particular type of solution you're looking for them to develop? For example, reversing the direction of the ball or making more long passes. Having these things in mind is not only critical for developing effective constraints manipulation, but it also allows a coach to better identify what a successful outcome of a CLA manipulation should look like. A tool that many proponents of the CLA, including myself, like to use for this is a constraints matrix, where you lay out different constraints that can be manipulated in practice for your sport and connect them with different goals. I will be covering this in detail in a future episode. To wrap up this systematic review, what types of constraints manipulations did the authors find to be most commonly used? Quote, the most frequently manipulated task constraints were related to playing area dimensions, pitch size and practice spaces, numerical relations between players on different teams, using equal and unequal numbers of players, and the imposed rules of practice matches. The studies where playing dimension and space were manipulated revealed that larger playing areas promoted higher levels of variability in player movements, more opportunities for creating overloads and gaining numerical advantages, higher levels of physical performance, as well as an elongated team playing shape. Moreover, studies focusing on the role of manipulating player numbers involved in small-sided games suggested that numerical relations between teams clearly constrained inter-team coordination, mainly in situations of numerical disadvantages between competing teams. End quote. There are relatively few studies that have attempted to manipulate environmental or individual constraints, likely because task constraint manipulations are just easier to use. The second study by Ramos and colleagues I want to look at is one also published this year in the journal Research Quarterly for Exercise and Sport. In it, the authors attempt to address one of the shortcomings identified in their systematic review, looking in more detail at how exactly constraints manipulations have their effect on team behavior. For this, they focus on the development of tactical knowledge in sports. As I discussed a bit in my last episode, when talking about knowledge from an ecological viewpoint, it's important to make a distinction between Gibson's knowledge of and knowledge about our environment. To quote the authors, the constraints-led approach to coaching and teaching emphasizes how, through task constraint manipulations, athletes can gain a profound adaptive relationship, development of specialized comprehension underpinning tactical configurations of play under the effects of different interacting environmental constraints. This type of knowledge of a performance environment facilitates a deeply entwined and integrated relationship between knowledge, perception, and action to support learning and performance in sport. In ecological psychology, a performer's contact with a performance environment is based on knowledge of the environment, which is deeply integrated with the process of perception and action that support decision-making. End quote. So key point here, Knowledge of is developed and expressed by acting on our environment. Knowledge about, on the other hand, refers to symbolic or representational knowledge of the environment, which can be gathered and expressed passively. For example, having an athlete learn from whiteboard drawings and express the decisions they would make in different situations, either by drawing on a board or verbalizing them. So it's essentially declarative knowledge from an information processing view. From here, the paper takes a bit of a strange turn for me, because the authors begin to blend these different types of knowledge together. First, they seem to be suggesting that knowledge about can enhance knowledge of. For this, they appeal to the concept of understanding from the teaching of games for understanding approach. Specifically, they propose and go on to test the idea that the step game approach can be combined with the CLA to improve tactical skill in sports. In the step game approach, players are presented with game-like tactical problems in a step-by-step manner, so that they develop tactical knowledge and understanding through question and answer sessions with a coach. As I discussed in episode 172, using games to develop understanding in this way is a very different and somewhat incompatible goal to using games for the purpose of self-organization and exploration of the perceptual motor landscape. This incompatibility can be seen in the main instructional principles from the step game approach outlined in a table in the paper. Quote, players must be given opportunities to develop the experience of recognizing appropriate cues from a variety of domains. In an ecological approach, actors use information, not cues. Quote, questions were generally related to a specific technical aspect and guided players to constructively build a solution. In an ecological approach, actors don't mentally construct things. They pick them up directly from the environment. Quote, what the player does in the process of using declarative and proceduralized knowledge. Again, not an idea compatible with the ecological approach. And finally, quote, indeed the relationship between tactical needs and movement is such that knowing facilitates perceiving and doing. In an ecological approach, knowing does not facilitate doing. They are reciprocally and inseparably coupled. On the surface, maybe these sound like just semantics to most people, but they get at the heart of the very differences between the ecological approach to perception and traditional indirect approaches. The second big issue I have with this paper is that the effectiveness of a CLA approach is evaluated solely by looking at the verbal responses given by athletes to questions about tactical situations in interviews. This is very odd. To quote from the paper I discussed in my last episode, which had some of the same authors as this one, it is also of relevance that in an ecological dynamics rationale, questioning methodology used by a coach needs to be responded to by an athlete's actions, not verbal responses. End quote. In other words, knowledge of cannot be assessed with just verbal responses. I am all for trying to mix methods and break divisions down in the skill acquisition area, but for me, this is a perfect example of why you shouldn't mix approaches based on different theories of motor learning. It leads to logical inconsistencies and interventions which support completely different purposes. Maybe I'm being overly critical here, but simply overlooking things like the fact that one approach talks about information and the other talks about cues is problematic. But anyways, let's look at what was done in the study. To foreshadow, in the last paper I'm going to talk about today, the authors did go beyond just the Q&A to measure the movement behavior of the athletes in the study. In the study, 15 female volleyball players from the Portugal National Premier League participated. The study was conducted across the full length of a competitive season and included 2 separate competitions. Training involved using a variety of different task constraint manipulations, including the position and numbering of players and the rules of play. For example, players were instructed they had to attack from a certain side of the court in one session, and instructed they had to keep their hands between the net and a rope fastened to it on another. The table in the paper actually gives a really excellent example of how to connect practice objectives to specific constraints manipulations. Data collected in the study was in the form of a reflexive diary from the coach describing the process of using the CLA and Q&A focus group interviews with the players. These data were split into 3 cycles of training. What was found? In cycle 1, players were able to verbally describe their knowledge about their opponent's tactical behaviors, knowing what, declarative knowledge, and how, proceduralized knowledge, they could perform an action. However, they were not yet capable of verbally describing the tactical perceptions, decisions, and actions undertaken, based on knowledge of opposition behaviors perceived and acted upon. Players were capable of perceiving opposition placements, but were not able to identify critical information sources. By cycle 3, quote, players started to establish a connection between the purpose of a constrained practice task and the tactical demands of competitive volleyball. Manipulation of task constraints in practice seemed to 1. Guide the player's attentional focus, and 2. Stimulate their understanding of different game scenarios and increase the repertoire of performance solutions available to them in offensive and defensive game subphases. The authors sum up the results of their study as follows, quote, "Results suggested that the development of players' tactical knowledge benefited from a mutual integration of different yet complementary pedagogical approaches. By integrating the step game approach and the CLA, it was possible to enhance players' adaptable thinking, using learning tasks involving the manipulation of meaningful constraints that afforded variable repetition and the resolution of tactical problems." Not surprisingly from what I said earlier, I don't really agree with these conclusions. Because only verbal responses are used in the study, what it shows to me is that the CLA training can increase abstract knowledge about tactics and skill. I don't agree that these methods are complementary, as they have fundamentally different goals. Also problematic is that there's no comparison or control group in the study, so it's hard to determine what actually caused the effects observed. More on that in a second. So overall, while I like the idea of trying to provide more rationale and purpose for constraints manipulations, I don't think this is the way to go. If you want athletes to increase tactical knowledge, use questions and instructions as constraints which guide their movement behavior, like as I discussed in the last episode. Finally today, and linking the two papers I've talked about so far together, in a paper published in the Journal of Sports Sciences this year, Ramos and colleagues analyzed positional tracking data collected during the practices and competitions from the volleyball study I just described. This was done to assess the formation of synergies in team play. So, this truly is evaluating knowledge of by assessing actions. The authors begin by emphasizing the importance of this synergy concept in volleyball. Quote, "Particularly in volleyball, the ability to perceptually attune to different affordances can be critical during the counter-attack phase when the opposition has possession of the ball. Accordingly, to overcome the unpredictability of the opponent's offensive organization, a team must exploit synergy reformation tendencies as players self-organize defensively, increasing the odds to score. Despite the extensive research undertaken so far, there is a need for investigations that determine coherent links between the task constraints manipulation and the resolution of tactical issues that emerge during competition." End quote. So again, referring back to their systematic review, we need a better link between the constraints used and what the coach is trying to achieve in a particular practice session. In the study, team synergy was assessed by filming players during practice and the gameplay and calculating a measure called the Hilbert transform of the positional data. This was then used to calculate the phase of movement for each player individually and the phase of the movement of the cluster as a whole. Synergy is assessed by calculating the difference between these two, with a smaller difference reflecting greater synergy. The effect of 3 different variables on this synergy were analyzed: tactical complexity in the practice design, the set moment, the initial or final set in a point, and of course the phase of training. The training was as described for the last study. What was found? A higher level of team synergy was found during the final set moments as compared to the initial. Interestingly, from the first to second cycle of training, as the tactical complexity of the sessions increased, there was a decrease in team synchrony, but this increased again in the third cycle. This is similar to the fact I discussed earlier, where adding variability to practice initially decreased team coordination. And perhaps we can interpret this as evidence of an exploration followed by an exploitation in movement solutions. The authors conclude that, quote, "Introducing more complex tactical organizations leads to a reduction in a team synchronization, with the re-achievement of functional synchrony being facilitated by combining the CLA and step game approaches in practice design to enhance players' tactical awareness during competition." Although I really like the measures being used here, for me this conclusion is premature. As I stated, not only are the step game and CLA approaches incompatible in many ways, without any kind of comparison group, we have no way of knowing whether their combination actually improved or benefited anything. As the authors discussed in their systematic review, there's a large body of research showing that the CLA affects team coordination and synergy, so it alone could completely explain the results found in the study. So in sum, my takeaways from this interesting series of studies by Ramos and colleagues is that there's good evidence that the CLA can be used to develop effective tactical behaviors and decision-making in team sports. But we need more research illustrating how the specific task constraints are used to address specific practice goals. Okay, that's it for today's episode. Remember, you can contact me at robgray@asu.edu or follow me on Twitter at ShakyWeights. To find out more about the podcast, please check out perceptionaction.com. Finally, to support the podcast to receive bonus materials, including written transcripts, please head over to patreon.com/perceptionaction. This is Rob Gray from ASU. Cheers for now, and keep 'em coupled.